Are you confident preparing a boot firmware for Zynq 7000 SoCs yourself? If the answer is yes, then how long will that take? Now with GenZ, the open source BSP generator, and OpenXC7, it can be done in less than 5 minutes. The instructions are here. First, we can clone the GenZ repo, and then we can go to the examples and this no DDR SD boot. There's a comprehensive instructions here. You just need to follow it. First, we can run this GenZ to generate the BSPs. We can see this program calculated all the frequencies, the PLL parameters, and set it up those MIO pins to our desired peripherals. It will create a output result here. If we can have a inspection here, it mainly consists of this PS7 init, which is made of all of these register writes to the ARM cores, and also this x parameters.h, which set up the parameters that is used by the Xilinx embedded software library. Here we have addresses for UART, we have frequencies of the ARM cores, and some other parameters. Then we can clone this Xilinx embedded software library. It's my branch here, which contains the no DDR SD boot support. We can create a new folder of the BSP and then copy our generated results inside. Then we can just compile the FSBL or first stage bootloader and our user application. It's very straightforward. The toolchain is the open source one in the Linux distributions software repo. We can see that hello world, ELF are already generated. In this hello world.c is a very basic demo. We have a dead loop here that writes to GPIO address to blink some LEDs and print hello in a loop. Now the software preparation is done, and we can compile the FPGA bitstream, which is done by OpenXC7. It's the open source toolchain. We already have some pre-generated makefiles, and what we need to do is just to run this runcas.sh. It contains a docker run command that runs the toolchain inside the Docker file, so we don't need to install this locally. Now it runs uses and next point and root and bitstream generation. It only takes 5 seconds to generate a bitstream for Zynq 7020. Now finally, we can create this BOOT.BIN, which is placed in an SD card for Zynq to boot from. We will use this Zynq mkboot image by Ant Micro. We'll just compile this locally. It relies on a BIF file to specify what's inside this boot.bin. It is the same as Xilinx SDK. We have our FSBL, then bitstream, then the user application. With this one command, we can see that a boot.bin has been generated. It is just a data file. Then we can place this one into the rootfs of an SD card. We will just copy this one to override the existing one. It is this simple. Then we can plug in this SD card back to the board and set the boot mode to SD. The power cable is connected here, where JTAG and UART is not connected yet. Now we can just flip the switch. And in 1 second, we can see the bitstream have been loaded, and the LEDs are now blinking. Now we can connect this USB to UART and JTAG cable, and then launch the console. We can see hello have been printed here in a loop, so the bitstream and our user program on the ARM cores are all working fine.